Okay, so we're going to look at some probability questions now. So we've got a classic question where there's a variety of options, and we've got 3 red pens, 4 blue, 5. So altogether there's 12 pens, and taking a pen at random, that means every pen is equally likely to happen. Write down the probability it takes a black pen. Well, what we've got to remember a probability is the answers can be fractions, decimals or percentages. But quite often it's easier to think of them as fractions first. So the number of black pens was 5, and there were 12 pens altogether. So the probability of taking a black pen was 5 out of 12. But say we've got to write it as either a fraction, decimal or a percentage. So the answer here would be 5/12. It then says what's the probability that Samina takes a pen that is not black? Well, what we've got to remember is that not black is everything else. So we had 5 black pens, so there must be 7 of the others. So the answer here will be 7/12. Again, we should recognise that 5/12 plus 7/12 is equal to 12/12, the whole. So when we want something that's not, then we look at what was and then take it away from 1, and that's usually a way of checking. So simple probabilities, fractions is usually the best way of thinking about those kind of questions. Okay, so another probability question then, guys, that was on your assessment, was the idea of spinner spinning, and we could see that there was different fractions of sections, so therefore it was more likely to be blue on each spin and so forth. So the question went on and gave you some probabilities. And we should know that all the probabilities for all outcomes, if we know them, must add up to 1. So when it says work out the probability that it will stop at blue, then we've got to recognise we do 1 take away all the other probabilities added together. So we got 0.35 plus 0.1, 0.45 plus 3, 0.75. So that's 1 take away 0.75. Which gives us an answer of 0.25. If we're not happy in doing decimal takeaways, then quite often think of them as percentages, so 35%, 10% and 30%. Add those together, you get 75%. Take that away from a whole, 25%, and as a decimal, 0.25. The next part of the question goes on and talks about what's the probability that the wheel will stop at either yellow or red. Well, when we look at the table, we can see that the chance of yellow was 0.35 and the chance of red was 0.1. So yellow or red, then we'd add those probabilities together because the or is implying that either one counts, and therefore you'd expect the probability to get bigger for that event, that outcome to happen. So when we add those together, then we get 0.45. When we're adding decimals, then we should make them the same length. And then we've got 0.45. Okay, so that's a question involving finding probabilities to do with mutually exclusive outcomes and tables. Remembering that all the probabilities, if we know them, then all the outcomes have to sum up to 1. Okay, so we then moved on to probability through tree diagram. So let's find that question. Okay, so this time then we've got a situation where somebody's taking driving tests and it's telling us some conditions. The probability that Tom is 0.8, the probability that Sam is 0.6. So we can show what happened, probability that Tom passed followed by what was happening with Sam. And we should remember that from each event all the outcomes should add up to 1. So there's only 2 outcomes here, then the missing outcome here is 0.2. Because 0.8 plus 0.2 equals a whole 1. From this one then, Sam had a probability of passing of 0.6, so the probability of failing must be 0.4, so 60% chance of passing, 40% chance of failing. And again, we should notice that those 2 add up to a whole 1. Again, we've got 2 outcomes here, so they should add up to 1, so that'll be 0.4 as well, because the other one was 0.6. Excuse me. Right, so work out the probability that both Tom and Sam will pass the driving test. So it's both Tom and Sam will pass. Well, if we follow the tree diagram, then we want Tom and Sam to pass. So Tom passing went there, and Sam passing went there. So we ended up at this particular juncture. So 0.8 followed by 0.6. Well, we've got to remember that when we come across branches on tree diagrams, we end up multiplying the probabilities. So the probability of a pass followed by a pass is going to equal 0.8 times 0.6. So it's a non-calculated paper, so it's a non-calculated question. So 8 sixes are 48, and then we got two digits after the decimal point in the original calculation, so there must be 2 digits after the decimal point in our answer, so 0.48. So the answer here then will be 0.48. The question then goes on and says work out the probability that only one of them will pass the driving test. So only one of them will pass. So Tom passes, Sam fails. That would be a condition for part C. And Tom fails, but Sam passes. That will also be a success, because only one of them will pass through those conditions. So therefore we've got two probabilities to work out. So when we get to this particular part of the tree diagram, we picked up Tom passing, and then we got Sam failing. So that gave us 0.8 times 0.4. So come across, then we times, so 0.32. Tom failing first time, and then Sam passing. So that will be 0.2 times 0.6, which will be 0.12. Now, because these two outcomes count for this particular question, because they both have one person just passing, then the probabilities get added together because both of them work. So we must do 0.32 plus 0.12, so 0.44. So the answer here then, 0.44. Okay, so tree diagrams, just got to be a little bit careful that we follow the branches to get to the outcomes of the two events, and we multiply as we come across the tree diagram. And if we know that there's more than one outcome that actually works for final answers, then we add them up as we come down the tree diagram. And the other important bit to remember, guys, is that the outcomes must add up to whole 1 from each event. So the way of finding missing values is to make sure it adds up to 1. So that's a run through of probability and how to work with tree diagrams in this particular case.